Okay, so make sure that you guys have these 5 items. They do not have to be in that order, but those are the 5 items that you've been getting out that you're going to turn in with your warm up. Okay, sorry, with your quiz, you're turning it in. So here we go. In yesterday's warm up, I want to talk about the goal, the reason for number 1. The goal of number 1 was to make sure that you could understand what items affect the mean and median, and that is addition and multiplication. So mean and median are affected by both addition and multiplication. Okay? So on those, we wanted to add 35 after you multiplied by 73. Okay, now on this, the standard deviation and the IQR, these are measures of spread. So I want you to think of this picture. If you have a box plot and you are shifting it by adding it 35, the spread is not changing. So adding and subtracting is not changing standard deviation or IQR. The only thing that is changing your standard deviation or your IQR is multiplication. That changes the size of the spread. So therefore, those are only getting affected by multiplication. So we are only multiplying by the 73 on those 2 problems. But here we were multiplying and adding. Okay, next. Number 2 was something that was unusually high, so I applied the outlier rule to that. And so both of those here, depending on which one you chose, so you could do the Q3 plus 1.5 IQRs, which gave you 25 hours. So yes, 28 is outside of that. It's higher than that, so it's an outlier. If you chose the other rule, which is the mean plus 2 standard deviations, okay, then you got 22.57, so 28 is an outlier for that one also. Okay? Any questions there? Alright. Then this last one, let's make sure that you are including everything that you're supposed to include on your pictures. I want you to include 2 rows of information below the picture. Okay, and I actually did not have this written in, and you need to. So I'm labeling that this row is all the z-scores, the mu, the 1 sigma, 2 sigma, 3 sigma, and so on. And you need to put some kind of context label here. It was kind of a confusing concept for me. I didn't really know if it's measured in points or what. So I just kind of like put, this was the Wechsler Adult Intelligence Scale, and so then I put those numbers there. So if you write something like data, that's too general. So do not just say, oh, here's my data. No. I need specific to the context. All right. Next. Number 3, you're asking which dog is more underweight. And the implication of that is relative to its own breed. Okay? Because you wouldn't want to compare, a Chihuahua against a Great Dane and see which one's more underweight. It's relative to its own breed. So you compared the Dalmatian to average Dalmatians, and you got a z-score of negative 1.51. You compared the Boxer to the average Boxer, and you got a z-score of negative 3.23. Now, this right here, I don't think that this is extra information. I know that as a teacher, a lot of times I write a whole lot of extra things because it's just for the teachery aspect so that anybody looking at it can tell why I put that. But this is not, to me, this is not excessive. Because it does ask for you to explain. So I said, I answered the question, the Boxer is more underweight because, so here comes my explanation. And it's because the Boxer is over 3 standard deviations below average, and the Dalmatian is only 1.5 standard deviations below average. Okay, so that's what I wrote here. So that is not like too much to write. You need to include that much information as your explanation, because it's in a reference to how many standard deviations it is below the average. Okay, any questions on that part so far? Okay. Our last one about temperatures. Most everybody did great in finding this location of the 97 degrees. Okay, so that was good. Everybody did pretty well with finding that that was a z-score of negative 2.4286. But where you got stumped yesterday was finding that percent of people less than that. So we kind of got stuck in, we don't know how to like turn this into a percent. Okay, so that's an area. So when you're doing an area, you do your norm CDF from the lowest z-score to the highest z-score, and that's how you can get your percentile. That's how you can get the percent of data down there. It wasn't even 1%, so pretty small. Now, I will tell you that a lot of people ask me, how can you tell the difference between what you do with inverse norms? They get confused on what you're using inverse norm for and what you're using norm CDF for. So I'm on the search for some way to kind of remember this, and I don't know if you have a way to remember it or not, but I thought, well, if you're looking at the words, this is like a 1, and you put in one thing here. All you are putting in is one item, it's the percent. But look here, on your norm CDF, you know, you've got these two lines here, and you have to put in the low z-score up to the high z-score, so you are having to put in two numbers to get this area in between those two things. So I know that that's just kind of a weird way to do that. I don't know. Anybody come up with another way?
Yeah.
Okay, what?
Well, like you're saying 1, you should put this one. So out of 1.
Okay, so this is 1, and so he's saying you're thinking of it out of 1, so you're having to put a percent in because that's out of 1 whole. Okay, there's another one. Anybody else come up with that? And actually, last period, somebody else came up with this and said, hey, you know what? That N, guess what that looks like? It's your Z. Okay, so... No, do you like that one? Okay, I don't know. So, because you need two of them, you need the low Z and the high Z. Okay? So, anyway. So, I'm in search of a good way to help students remember the difference between those things, but you need to get to that point where you know that norm CDF is getting that area, that percent, that shaded amount. All right. B. B asks for the interquartile range. This was just like the first paper I taught you yesterday, where you had to identify the Q1, the Q3, and then subtract them. I did have some people that kept more decimals, and that was actually probably more accurate. I probably rounded too much right here. Just tried to make it pretty easy. But I had some people get more specific in terms of 0.94 to something else, and that's great. That's fine. Please don't forget that I need your formulas shown. These Z formulas are a necessity. All right, the final one. Okay, so this one seems to be the one that we had most trouble on, so let me walk you through that. So when they are telling you on this problem that the IQR, so this is in degrees, the stated down here is in degrees, but when they tell you that the IQR is 1/2 of a degree wide, that has to do with the variability. IQR is having to do with the spread. See, if your IQR is smaller, then your curve's going to be smaller, and it's going to be shifted in. So when they're referencing the size of this IQR, it's indicating how spread out the data is. Okay? All right. Well, what you needed to do is identify everything at one of your quartiles. either Q1 or Q3. I did both of them here, okay, depending on whatever you did. But let's just do all the data at Q1. Okay, so what is the z-score for Q1? Good, that we had come up yesterday, inverse normal 0.25, negative 0.6745. Good. We need to find the x value. That's the temp, the temperature. So how can I get this temperature here? Not plugging it into the z-score formula because I don't have standard deviation, so I couldn't do that. Normally you would if you had standard deviation, but I don't have that. It comes from this picture.
Oh, yeah.
Since this is a half of a degree all of the way across here, then how much is it for the left half is a quarter of a degree. So to get that temperature, you're doing your 98.7 degrees minus a quarter of a degree, and that's how you get 98.45 degrees. Okay, so I got that. It's 98.45 degrees. And then the mean referenced on this page is 98.7 degrees. So now I have 3 items in reference to one location, and then that is when I can put 3 items in and solve for the 4th. And that's what this question wanted, was the standard deviation. Okay, so then you can put those 3 items in and solve for the 4th. Okay, and so in doing that, it looks like this up above. You get a standard deviation of 0.3706. This side is doing it with the Q3 information. This side is doing this computation with the Q1 information, and it did not matter which one you chose. You came out with the same answer. Okay, so there's your warm-up. I will tell you that in my other classes, the option to go over some homework questions was given, and they chose